I know you can't see that very well because of this tiny font, but you already have this problem that you should have written down from your notes. So suppose a balloon begins descending at a rate of 20 feet per minute from an elevation of 1,350 feet. Write an equation to model the balloon's elevation as a function of time. Okay? So a function of time, so we'll have f of t, okay, equals, it's starting at 1350. So we're going to start here at 1350, and then they are descending, which means going down at a rate of 20 feet per minute. So negative 20t. I'm going to rearrange this so it's in slope-intercept form. So it should be f of t equals negative 20t plus 1350. I think the book actually had this as h equals negative 20t plus 1350. H being the height, or elevation. Sorry. So then this asks us to graph the equation and then interpret the intercepts. Alright, so to graph this equation here, I'm going to go up 1350, I'm going to go by hundreds here. My scale is going to be 100, so there's 100, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I know, and then this will go by, might as well go by 20s. 20, 40, 60, 80, 100. Okay, I hope that's far enough. If not, I'll make an adjustment. Okay, so we go up 1350, right? Plot your y-intercept first. So put a dot there, so I'm going to plot that B, my y-intercept first, 1350 is right there. And then negative 20, so that would be negative 20 over 1. We'd scroll all the way down. So because my scale is off though, it's going to throw this off. So let me just graph this on my graphing calculator and see where my x-intercept would be. Or better yet, I'm not going to use that. I'll use the fact that I know for my y, or my x-intercept, y equals 0. So 0 equals negative 20t plus 1350, and let's solve. Negative 1350, so I'll have 1350 divided by negative 20, and that is t, sorry, it's going to be a positive 20. Negative 1350 divided by negative 20 is 67.5. So my x-intercept would be 20, 40, 60, and that's 80, so 67.5 would be about there. Okay, and let's talk about what this represents. Okay, so what do these intercepts represent? Well, obviously this one's not too hard to identify because it gives us in the original problem. That's the initial height of this balloon. Okay, 1350. That's its elevation when we start this discussion or this function. This intercept, well, we're talking about how it is descending in the air. So if this is the air, if it hits here in the x-intercept, that's where it's landing. That's the ground level. So after 67.5, what is it, minutes? Is that what time is? Minutes. So after 67.5 minutes, it's going to hit the ground, which makes sense because hot air balloons normally I think are like an hour is how long you're in them. Okay, part 2, example 2. A candle is 7 inches tall after burning for 1 hour and 5 inches tall after burning for 2 hours. Write a linear equation to model the height of the candle. Okay, so it's kind of inadvertently giving you 2 ordered pairs. So I'm going to say time and then height, because height is a function of time, so height is always going to be your y, and time will always be your x. I don't have to graph this, so I won't. But, so my two intercepts are gonna be 1, 7, and then 2, 5. Because it's 7 inches tall after burning for 1 hour, and 5 inches tall after burning for 2. So I'm gonna use those 2 points to find the slope, and then use one of the points to plug in to find my y-intercept. So I'm going to use my slope formula, 5 minus 7 divided by 2 minus 1, that's negative 2 over 2, which is negative 1. So I have y equals negative 1x plus b. From here you can use your point slope form to figure it out. Clearly I already have it in y-intercept form, so that's what I'm going to use. I'm going to take one of my ordered pairs, plug it in for x and y, and find my b. I'll choose 1 and 7. So we'll have 7 equals negative 1 times 1 plus b, which is negative 1. Okay, add the 1, so I'll have 8 equals b. So my y-intercept is 8. Okay, what does the y-intercept represent? Okay, your y-intercept in this is representing the initial height of the candle. When you bought it, or before you started burning it, that's how tall it was, 8 inches. What does the slope? Oh, that's wrong. Shoot, all this is going to be wrong. Okay, let me fix it. So this is negative 2, which means this is negative 2. So that means our y-intercept is 9. Sorry. If I would have thought of the context of the problem, I would have realized I was wrong. Okay, anyway, so the initial height is 9 inches, and then our slope of negative 2 is representing that every hour that candle is burning off 2 inches. Okay. And then example 3, graph each set of data, preferably in different colors. Decide whether a linear model is reasonable. If so, draw a trend line and write its equation. Okay, so here, let's graph each set of data. I don't think any of them are negatives, so we'll stay like this, and I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Scale of 1s for each, so no big deal. Okay, I'm going to do A in red. So we're going to go 1 and 5.7, 2 and 6.8, 3 and 8.2, 4 and 9.6, and then 5 and 10.9. Okay, then B, I'm going to graph in green. 1 and 5.4, 2 and 6.2, 3 and 7.7, 4 and 9.1, 5 and 10.5. Okay. Linear model reasonable? Heck yes. This is strong correlation positive, so I would definitely say a linear model is reasonable. So let's draw a trend line. Now make sure with your trend line you have about the same number of points above and below the line to really identify what that trend line is. So I would say it's something like that. Would look pretty decent. And then from here you can either pick 2 points on the line. We are going to actually plot this in on our graphing calculators, and your graphing calculators can identify that trend line. And then I'll show you how to use ordered pairs to actually write the equation of that line for that, like we just did for example 2. So there's that, and make sure you look at the links for how to use a graphing calculator to graph that trend line and plot those points. If you have questions, we will talk about example 3 tomorrow, or the next time we go through this. So if you have questions, make sure you bring that in and ask.